Hi students, in these notes we will learn how to actually begin writing proofs which prove how two triangles are congruent using SSS, SAS, ASA, or HL. So we're taking what we did last time, but we're formally kind of writing it up so that we can explain our thinking. So we'll go over the steps first and how to make a proof, but I want you to know what they look like first. So it's basically like a T-chart. On the left, you have your statements. These are things that we know are true. And then on the right, we have our reasons. And this is where we put the reason why we know the statement on the left is true. So what's on the right, these are just kind of like justifications for whatever we're saying on the left. Okay? So you always kind of start with what you know and then kind of work from there. So let's look at the actual steps to do this, and then we'll try some proofs together. So whenever you're asked to make a proof, the very first thing you do is you're going to use the information that's given to you, and you're going to mark your picture. Okay, so you'll have some sort of a picture, and you'll have information. Sometimes some of the information will already be on your picture, but if it's not, you want to mark your picture. If you don't have a picture, you definitely need to draw one, but we'll always have a picture on ours, okay? After you've marked your picture, then you're going to begin your proof. So the very first statement that you put in your proof should be the first information that was given to you. It's called your first given, okay? And the reason you put for anything that's already given to you is given. Okay, it's really easy. So the first statement and reason in a proof are super simple. Then from that one given, step 3, we're going to deduce all the possible information from that given until we can make a congruent statement. So the congruent statements we're looking for are those S's and A's that we talked about last time, okay? And I kind of wanted you to get in the habit of writing S's and A's off to the side with a circle because that's going to help you with this part. You would also maybe, if you're trying to use HL, you would want a congruent statement that says your hypotenuses are congruent or your legs are congruent, okay? So you're trying to get to one of these statements, and it has to have a congruent symbol in the statement in order for us to say it's an A, S, H, or L. Then you're going to continue this process. So then you'll go with your next given, and then you'll repeat step 3. So you'll use up all your givens. You'll write your givens, reason given, conclude everything you can from that given to get a congruent statement, and then you'll go to the next given and then just repeat this. Okay? If you've used up all your givens and you don't have the 3 congruent statements, the 3 being either SSS, SAS, ASA, or the HL and the fact that you have a right angle for HL, then, so if you don't have all that yet, then you're going to look for some things. You'll look for a reflexive side or angle. This is when the two triangles share a side or they share an angle if they're overlapping triangles. Or you'll look for a pair of vertical angles, which are always congruent. So those could be kind of hidden in your picture. Then once you have all 3 of those congruencies, now you can determine that the triangles are congruent by either SSS. So sorry guys, those were my sons. They were killing each other. So as we were saying, step 6, once you have all the 3 congruencies that you need, you can determine if the triangles are congruent by SSS, SAS, ASA, or HL. And you will actually put those as your reason. So the very last statement will be your prove statement. And it'll always give that to you at the very beginning of the problem. It'll tell you what you're trying to prove. You're probably trying to prove that the 2 triangles are congruent. So you'll write that triangle congruent statement on your last line for this statement. And then your reason is either going to be the SSS, SAS, ASA, or HL. And that's for now, because we'll get one more step later. Okay? So let's go ahead and try some of these. All right, so here's what it looks like when you're doing a proof. You're going to have some given information. That's stuff you can use in your proof. And then you're going to have a proof statement. That always goes at the very bottom. That'll be your last statement. So you could even start by putting it at the bottom. The only thing is sometimes you don't know how many lines you'll need in your proof. So you might want to wait till the end. But I kind of pre-told you how many lines it should be. So we're trying to prove these two triangles are congruent. And we're trying to figure out what reason, right? So this is kind of what we were practicing in our last unit. If you just look at these triangles, right, let's go ahead and first put the information that we know on the triangle. That's step one, to mark your picture. So the first thing it says is AD is congruent to AB. AD and AB. So you show those two segments are congruent with tick marks. Second one, DC, segment DC, is congruent to segment BC. Okay, so now you try to get kind of like some ideas in your head about which one this could be. SSS, SAS, ASA, or HL. I already have two sides that are congruent. So I could either be SSS or SAS. I don't have any right angle, so it's probably not HL. For it to be SAS, I would need to know something about angle D and B, these two guys between those angles, but I don't know anything about those angles. So it could very well be SSS. So let's go ahead and start with those first two givens and then see what else we can see. So the very first statement is going to be your first given. That's this AD is congruent to AB. And your notation is very important, the way that you do your symbols, so you need to pay real close attention to that. Make sure your segments have the lines on top. Make sure you're using the congruent statement. The reason, anytime you write a given down, the reason is always going to be given. Okay, real easy. Now notice, this is a congruent statement. When you have that congruent symbol and it's one of your S's or A's or H's or L's, what Miss D does is I put a little S out to the side and I'm done with that given or that statement. I'm ready to move on to my next given. My next given is that segments DC and BC are congruent. So let's write that. DC is congruent to BC. The reason is given. Now I do have a congruent symbol and these do represent sides, so I'm going to put an S for sides. So now I already have two congruent statements, I need three. So let's say we wanted to see if we can do SSS. If we look real carefully at our picture, I notice that both triangles share side AC. So side AC on the top triangle is congruent to side AC on the bottom triangle because they're the same side. So let's make that statement. So sometimes you'll pick a statement from your picture that's not part of your givens. So we'll say that AC is congruent to itself, AC. Okay, now the reason for this, anytime something is congruent to itself, it's called the reflexive property. Reflexive property, and you can just abbreviate property. Okay. So that's the reason. Now, this is a congruent statement. It does show me one extra set of sides. So I already have three sides that are congruent. So we can say these two triangles are congruent on our last slide. And the reason is SSS. All right, so that's our first one. All right, let's look at another one. Notice this one's a little bit longer, and I've given you the number of lines in your table that you'll need. It'll tell you basically exactly how many statements and reasons you should have. So let's first start by putting our givens on our picture. Let's mark our picture. AC, segment AC, bisects angle DAB. Here is DAB. This is the angle DAB, okay? This AC bisects it or cuts it in half, which means each of these smaller angles are congruent. Okay, so that's how I would mark it on my picture. It also says that angles 1 and 2 are congruent, so we can show that on our picture. Now, notice angles 1 and 2 are congruent. That is a congruent statement. But AC bisects angle DAB is not a congruent statement. So from that statement, we'll have to create one. Okay? Now remember, our proof statement is that the two triangles are congruent. And it tells you, if you ever aren't quite sure how they're congruent, you remember, it tells you which vertices correspond and are congruent, right? All right, so let's go ahead and do this. We're going to start. Our first statement is going to be our first given. Segment AC bisects angle DAB. The reason we know this statement is because it is given. So you're being very logical, you're slowing down, you're just basically writing out and justifying your reasonings. All right, this is not a congruent statement though, so I'm not done with this. This statement led me to say, or to know that these two angles were congruent. That is a congruent statement, so I'm going to write that. Now, to show that those two are congruent, I need to name them. I can't name them both angle A because they're two different angles with the same vertex. So I need to name them both with 3 letters. So that top one I could call DAC or CAD. Make sure to put your angle symbol first. I'm just going to use angle DAC. And it is congruent to the angle below it, which I could either call angle CAB or angle BAC. Either one is fine. All right, the reason I know those are congruent, and this will be a new reason for you, is because of this word bisect right here. So we're going to say definition of bisect. That's the reason. And what we'll try to do after this is we'll come up with a list of possible reasons we can choose from. So if you see the word bisect, then on the next line when you state what is congruent, you'll use the word bisect in your reason, definition of bisect. Now this is a congruent statement because I see the congruent symbol, and because I have angles that are congruent, I'm going to put an A off to the side for angles. Okay, now we're ready to go to our next given, which is that angle 1 is congruent to angle 2. And the reason I know that is because it is given. Okay, now this happens to be a congruent statement. It is saying that two angles are congruent, so I'm going to put an A off to the side for angles. So right now I've got 2 A's, so I'm thinking it might be ASA. Now in order for it to be ASA, I need to say that the sides between those 2 pairs of angles are congruent. And if I look at my my triangles, the side between those 2 angles is the side AC that they both share. So remember, just like in the last example, I can say that that side is congruent to itself. AC is congruent to AC. Reason being because of the reflexive property, because it's itself, it's congruent to itself. That's what reflexive property means. Now this is a congruent statement, and it's saying 2 sides are congruent, so that's going to be an S. So then I look at my letters, I've got 2 A's and an S. So by ASA, right, I've got my angle side angle, I can say that these 2 triangles are congruent. So on the very last line, I'm going to put this prove statement. Triangle ABC is congruent to triangle ADC. Oops. There you go. Let's do a few more. All right, first thing, we're going to put our givens on our picture. We've got some midpoints. So remember what a midpoint is. A midpoint is the right in the middle of a segment, and it divides the segment into 2 smaller congruent segments. It's a bisector. Okay, so for that first given, C is the midpoint of segment BD. So this midpoint of C cuts it in half, which means that segment BC and segment CD are going to be congruent. The second given says that C is also the midpoint of AE. So that segment is also being cut in half. So we can say that AC and CE, those 2 segments, are also congruent. So I already have 2 pairs of sides. So for these 2 triangles, I'm thinking maybe either side, 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 or side, angle, side. So let's go ahead and do what we already know and then see what else we can see. So let's start with our first given. And feel free to abbreviate. So I'm just going to say C midpoint abbreviated BD. Okay, that's totally fine. Reason is given, right? But that's not a congruent statement. So I can't go on to the next given until I make my congruent statement. That given, though, allowed us to say that BC, segment BC, was congruent to segment CD because that midpoint cut that segment in half. The reason we know that statement is because of midpoint. So just like on the last one we had bisect and we said definition of bisect, we're going to do the same thing and we're going to say definition of midpoint. And there's all these abbreviations you can use, which are fine. DEFN is the abbreviation for definition, and technically there's supposed to be a line above the N. It's like shorthand. Did I do that on the last one? I did do that on the last, I just didn't explain it. Okay. So now that we have our first congruent statement, we look, those are segments or sides. So I'm going to put an S out to the side to represent sides. Now let's go to our next given. C is the midpoint of AE, segment AE. And of course we know that because it's given, right? But that's not a congruent statement, so we need to say the congruent statement that given helped us to make, which was that segments AC and segment CE were congruent. So segment AC is congruent to segment CE. Just like the last reason for the last congruent statement, we're also going to say definition of midpoint. And of course abbreviate. Okay, so this is a congruent statement because I see the congruent symbol. It's stating two sides are congruent, so that's an S. Now, if I was to use side, 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 I would need to know something about segments BA and ED, which I don't. So this is where I need to look more carefully, right? Remember, you're going to look for reflexive sides, reflexive angles, or vertical angles. Those were the things on step 5 to look for if you don't have your 3 congruent statements yet. Well, I do see a pair of vertical angles right here and here, and I know vertical angles are congruent, so I'm going to state just that. Since both of those angles have vertex C, I need to make sure to name each of those angles with 3 letters. So the angle C on the left, I could call either angle BCA or ACB. Pick one of those. And it's congruent to the angle C on the right, which I could either call angle ECD or angle DCE. So pick one of those. Now the reason we know those are congruent is because they are vertical angles. So that could be a reason. Now this is a congruent statement that states that 2 angles are congruent. So I'm going to put an A off to the side. I've got 2 S's and an A. So the congruence postulate that we would want to use would be SAS. And notice that that angle is between those 2 sides. So we're going to, on the last line, write our triangle congruent statement. Triangle ABC, and remember that's just right here. You just write that on the last line, is congruent to triangle EDC. And there's that one. We got one more. All right, let's put our givens on our picture. Let's mark it up. First given is segment HY is congruent to segment LY, okay? Next given, Y is the midpoint of segment WF, this one. So that means that segment is cut into 2 congruent segments, okay? I also see those right angles at angle H and L. So that's good. So we might have an HL thing going on here. So if we do, the HY and the LY, those would be the legs. These would be the legs. And then the WY and the YF, those would be the hypotenuses because they are across from the right angles. Okay, so let's go ahead and start with our first givens. Erase this. So our first given is segment HY is congruent to segment LY. And of course the reason is given. And that happens to be a congruent statement stating that 2 sides are congruent, but specifically 2 legs. So this time I'm going to put an L. So HL is a little bit different than the other ones. So now I'm ready to go to my next given. My next given is Y is the midpoint of WF. And that, of course, is a given. But it's not a congruent statement, so I need to use it to make a congruent statement. The congruent statement we can say is that those two segments on either side of Y are congruent. WY is congruent to segment YF. And the reason is because of that midpoint in the statement above. So we'll say definition of midpoint. This is a congruent statement. And these happen to be the hypotenuses. So not only are they sides, but they're hypotenuses. So remember, HL is a little bit different. The other thing you have to do with HL, so you'll have an H and an L, but you also need to state that you have two right angles. You don't have to state that they're congruent. You just need to state that you have two right angles. And I can see those from the picture. So the way that we're going to write it is like this. We'll just say angle H and angle L are right angles. And see, I'm abbreviating everything. It doesn't have to be fancy. The reason is if you just pull it off the picture, you would just say diagram. Okay, you just saw it literally on the picture. So rather than listing it over here with your givens, it was just shown right on your picture. Okay, now off to the side, this is not a congruent statement. It's the right angle statement. So we're just going to put an R for right angle. So whenever you're using HL, you want to state that the hypotenuses are congruent, the legs are congruent, and that you have right angles. Once you have those three things, now we can say our triangle congruent statement, which is triangle WHY is congruent to triangle FLY. All right, I'm sure you've got some questions, so mark those down and ask me in class, and I'll see you soon.